Hello everyone, my name is Deepak Mani and this is my third lecture on differentiation. So in last lecture we find the derivative of some standard functions, and now in this lecture we are going to find derivative of composite function. So let us start. First we discuss about composite function. So let us consider two functions, f of x is equal to log x, g of x is equal to sin x. Then f plus g of x, which is equal to f of x plus g of x, which is equal to, here f of x is nothing but sin log x plus g of x is nothing but sin x. So this is called as addition of these two functions. Similarly, f minus g of x, this can be written as f of x minus g of x, which is equal to log x minus sin x. This is called as subtraction of these two functions. Then f into g of x can be written as f of x into g of x, that is log x into sin x is a product of these two functions. And f upon g of x, which is equal to f of x upon g of x, which is equal to log x upon sin x. This is called as quotient of given two functions. So similarly, the composition of these two functions is denoted by f o g of x, that is f of g of x. So here g of x is nothing but sin x, so here we write f of sin x, but f of x is log x, so f of sin x is log of sin x. So this log of sin x is called as composition of these two functions. Okay. Similarly, g of f of x is equal to g in bracket f of x, that is g in bracket f of x is nothing but log x, and g of x is sin x, so g of log x is sin log x. So this is also composite function of given two functions. Okay, so this is addition of two functions, this is subtraction, this is multiplication, this is division, and these two are called as composition of two functions, given two functions. And now we are going to find the derivative of such type of functions. Now first we are going to prove this theorem. So in this theorem, if y is equal to f of u is differentiable function of u, and u is equal to g of x is differentiable function of x, such that the composite function y is equal to f of g of x is a differentiable function of x, then dy by dx is equal to dy by du into du by dx. So in this example, first we are going to prove that y is differentiable function of x, and then we are going to prove that dy by dx is equal to dy by du into du by dx. So here y is function of u and u is function of x is given. So let there be a small increment in the value of x, say delta x, then delta u and delta y are the corresponding increment in u and y respectively, because u is a function of x and y is a function of u. त्यामुळे आपण समजा x मध्ये काहीतरी चेंज केला तर त्याचा इफेक्ट कुठे होईल, u मध्ये, आणि u मध्ये इफेक्ट झाला की त्याचा चेंज कुणात होणार आहे, y मध्ये. So delta u and delta y are corresponding increments in u and y respectively. So all these delta x, delta u, delta y are interdependent. That is, as delta x, delta u, delta y are small increments in x, u and y respectively, such that if delta x not equal to 0, then delta u is also not equals to 0, delta y is also not equal to 0. Now we have delta y upon delta x can be written as delta y upon delta u into delta u upon delta x. म्हणजे या ठिकाणी आपण delta u काय केलेलं आहे, ऍडजस्ट केलेलं आहे, because all these three numbers are not equal to 0. Okay, and by definition of derivative, limit of increment ratio is nothing but differentiation. So taking limit as delta x tends to 0 on both the sides, we get, in left hand side we get limit delta x tends to 0 delta y upon delta x, and in right hand side we get limit delta x tends to 0 delta y upon delta u into delta u upon delta x. पण आपल्याला माहिती आहे प्रोडक्ट असेल तर आपण लिमिट काय करतो, सेपरेट घेतो. So here we write limit delta x tends to 0 delta y upon delta u into, here we write limit delta x tends to 0 delta u upon delta x. Now as delta x tends to 0, we get delta u tends to 0. So here we are going to replacing this delta x by delta u. So this equation can be written as this limit delta x tends to 0 delta y upon delta x as it is, and here instead of this delta x tends to 0 we write delta u tends to 0 because these two have same meaning. Okay, कारण x मध्ये आपण डेल्टा एक्स चेंज केल्यामुळे u मध्ये डेल्टा u चेंज झालेला आहे. ओके, so delta x tends to 0 means delta u is also tends to 0. The reason is u is continuous function of x. Okay, but since y is differentiable function of u and u is differentiable function of x, so by definition of a derivative, the given function is differentiable means limit of increment ratio exists, and that limit is called as derivative. Okay, so here y is differentiable function of u, that is limit delta u tends to 0 delta y upon delta u, this limit exists, and this limit is called as derivative of y with respect to x and is derivative of y with respect to u, and it is denoted by dy by du. And similarly u is a differentiable function of x, that means limit delta x tends to 0 delta u upon delta x, this limit exists, and this limit is called as derivative of u with respect to x and is denoted by du by dx. So just substitute these values in equation 1, that is from equation 1 and 2. Left hand side limit delta x tends to 0 delta y upon delta x as it is. Now just substitute the value, so the right hand side become dy by du into du by dx. So here the right hand side of this equation 3 exists. Since y is differentiable function of u, so dy by du exists. U is differentiable function of x, that is du by dx exists. That is the RHS of equation 3 exists implies LHS is also exist. LHS exists means limit delta x tends to 0 delta y upon delta x exists. So by definition, if limit of increment ratio exists, then we say that the corresponding function is differentiable. That is limit delta x tends to 0 delta y upon delta x exists, that is y is differentiable function of x, and this limit is denoted by dy by dx. So just substitute this value in equation number 3. We get dy by dx is equal to dy by du into du by dx. So this rule is known as chain rule, and using this rule it is possible to find the derivative of composite function. Okay, see note number 1. The derivative of a composite function can also be expressed as follow. Y is equal to f of u is a differentiable function of u, and u is equal to g of x is differentiable function of x, such that the composite function y is equal to f of g of x is defined. Then dy by dx is equal to, now first we differentiate this function f, that is f dash of g of x into, now just multiplying by derivative of this g of x, that is g dash of x. For example, let us consider one composite function y is equal to log of sin x. So here the derivative of log x is 1 upon x, while the derivative of sin x is cos x, and now we are going to find the derivative of this composite function. So here the derivative of y is dy by dx. Now here first we differentiate this log x with differentiate this log with respect to sine. So the derivative of log x is 1 upon x, so the derivative of log of sin x is 1 upon sin x into, just multiply this by the derivative of sin x, so the derivative of sin x is cos x. That means the derivative of log of sin x is 1 upon sin x into cos x. Next, note number 2. If y is equal to f of phi is a differentiable function of phi, and phi is equal to g of u is a differentiable function of u, and u is equal to h of x is a differentiable function of x, then dy by dx is equal to, so y is a differentiable function of u, so differentiate this y with respect to v. V is a differentiable function of u, so differentiate v with respect to u, and u is differentiable function of x, so differentiate u with respect to x. This is also known as chain rule. So in theorem we find the derivative of composition of two functions, and here we find the derivative of composition of three functions. Okay, similarly in note number 3, if y is a differentiable function of u1 and ui is a differentiable function of ui plus 1 for I is equal to 1 to dot 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 n minus 1, and un is differentiable function of x, then that is y is a differentiable function of u1, u1 is differentiable function of u2, u2 is differentiable function of u3. Similarly, un minus 1 is differentiable function of un, and un is differentiable function of x. Then dy by dx is equal to, now first we differentiate this y with respect to u1 into u1 with respect to u2 into u2 with respect to u3 into dot 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 differentiate un minus 1 with respect to un into, and un is differentiable function of x, so differentiate this un with respect to x, that is dun upon dx. This is also known as chain rule. Thank you.